Hello everyone, a very warm welcome to ABC Trainings. Thank you for joining today's webinar. Today we will explore the career roadmap in data science, machine learning and artificial intelligence. Whether you are a student, a beginner or someone looking to switch careers, this session will give you a clear path to follow, the skills to focus on and tips to avoid common mistakes. By the end of this webinar, you will understand how to start your journey in data science and AI, the step by step roadmap for beginners, common mistakes to avoid, tips to build your career effectively. So let's start and understand the roadmap that can lead you to successful career in data science and artificial intelligence in 2026. What is data science engineering? When we hear the term data science, many people think it is only about charts or predictions. But in real companies, data science is much more than that. This is where data science engineering comes in. Data science engineering is a field that combines programming, data engineering, machine learning, and cloud technologies to convert raw data into meaningful business decisions. The goal is not just analysis, the goal is decision making. Then, why engineering in data science? In industry, companies don't want only models, they want systems that work continuously, handle large data, and give reliable outputs. That's that's why we don't just analyze data, we engineer complete data solutions. Then, core components of data science engineering. First one is a programming foundation. Programming is the base of data science engineering, used for writing data pipelines, automating tasks, building logic. Then languages of programming. Python, most important. Python is the most important in data science. Then SQL for data querying. For example, without programming, we cannot clean data, train models, or deploy systems. Then second one is a data engineering, handling data. In real life, data is a messy, huge, and comes from multiple sources. Data engineering involves collecting data from databases, APIs, files, cleaning and transforming raw data, storing data efficiently. Then tools, SQL and NoSQL databases, Pandas, NumPy, big data tools like Hadoop and Spark. For example, if data is wrong or incomplete, even the best ML machine learning model will fail. Then third one is a machine learning intelligence. Machine learning adds intelligence to data. ML is used to predict future outcomes, find patterns, then automate decisions. For example, predicting house prices, fraud detection, recommendation systems. Machine learning helps computers learn from data instead of being manually programmed. Then fourth one is a cloud and deployment production systems. A model is useful only when users can access it. Cloud and deployment includes hosting models on cloud platforms like AWS, Azure, GCP, creating APIs using Fast API, deploying models using Docker. When you open Netflix and get recommendations, that model is deployed on the cloud. Then data science engineering follows an end-to-end workflow. Business problem is defined, then data is collected from multiple sources. Data is cleaned and processed. Machine learning model is built, model tested and evaluated. Model is deployed on cloud. Business businesses uses the output to make decisions. Goal of data science engineering. The ultimate goal of data science engineering is to convert raw data into actionable business decisions. For example, which product to promote, which customer may leave, how to reduce cost, how to improve efficiency. Suppose an e commerce company wants to increase sales. Data engineering collects user data, then machine learning predicts customers' behavior and deployment shows recommendations live, and then business decision increases revenue. This is data science engineering in action. Then career perspective. Data science engineers are highly valued because they understand both data and systems. Roles like data engineer, data scientist, ML engineer, AI engineer. So, data science engineering is not about tools alone, it is about building intelligent systems that solve real business problems using data. Then, data science is not just about writing Python code or building models. In real companies, data science follows a step by step workflow. So, let's see end to end data science workflow. Each step is important, and skipping any step can lead to wrong result. Let us understand the end-to-end data science workflow from raw data to business decisions. So first one, sorry. So first one is a data collection. The first step in data science is data collection. Without data, there is a no data science. Data can be collected from databases like SQL, NoSQL, APIs, sensors, and IoT devices, CSV, Excel, logs, web scraping, etc. For example, an e commerce company collects customers' data such as clicks, purchase, and searches. More data does not always mean better data. Quality matters. So first step is data collection. Then second one is a data cleaning and processing. It contains raw data is always messy. It contains missing values, duplicates, and incorrect entries. These steps involves handling missing values, removing duplicates, fixing data types, handling outliers, normalization, and encoding. For example, if age is a written as 20 instead of 20, it means in integer. The model cannot understand it. Most of the time in data science is spent on data cleaning. So this is a data cleaning and processing. Next one is third one is a exploratory data analysis. EDA helps us understand the data before building models. EDA answer questions like what is the data distribution? Are there patterns or trends? Are features corrected? In EDA, tools used like Pandas, Matplotlib, Seaborn, these are the Python libraries which is used in EDA. For example, before predicting house prices, we analyze how price changes with location and size. The EDA helps convert data into insights. This is all about EDA. The next one is a model building. Once we understand the data, we build a machine learning model. In this step, select suitable algorithm, train the model using data, tune parameters. In common models like linear regression, logistic regression, decision trees, random forest, XGBoost, we train a model to predict whether a customer will buy a product. Then model learns patterns from past data. This all about model building. Then next one is a model evolution. A model is not useful unless we know how good it is. Evolution checks accuracy, precision, recall, F1 score, RMSE. If a fraud detection model misses fraud cases, it is dangerous. We test the model on unseen data to check performance. Then sixth one is a deployment. After evolution, the model must be made available for real users. Deployment means converting model into an API, hosting on cloud platforms, integrating with applications. Tools used for this are Flask, Fast API, Docker, AWS Azure, GCP. When you get movie recommendations, that model is deployed on the cloud. A model on your laptop has no business value. Then next one is the monitoring and optimization. Data does not stay the same forever. Models can become outdated. Monitoring includes checking model performance, detecting data drift, retraining models. For example, customer behavior changes over time, so models must be updated. So, optimization, which is improve accuracy, reduce latency, reduce cost. So, data science is a continuous process, not a one time task. Data collection, uh, data cleaning, EDA, model building, evolution, deployment, monitoring. This is the end-to-end data science workflow. Real world example for this is in a banking system, data is collected from transaction, cleaned and analyzed. A fraud model is built, deployed to detect fraud in real time and continuously monitored. This is example. Then end-to-end data science means taking responsibility from raw data to real business impact. Then we will see programming foundations, which include Python. End-to-end data science is over. Then we see programming foundations. Before we talk about data science, machine learning, or artificial intelligence, we must talk about programming foundations. And the most important programming language for data related roles today is Python. Python is not just a language to write small programs, it is the backbone of data engineering and machine learning systems. Why Python for programming foundations? Python is a easy to learn, powerful, and widely used in industry. That is why data engineers and ML engineers heavily on Python. The reason behind it simple syntax, strong libraries, easy integration with data and cloud tools. Then we will see core Python concepts. Core Python concepts from the base of everything we do later. This includes variables and data types, then conditional statements, loops, functions, list, strings, dictionaries, errors, error handling, etc. Then, without mastering these basics, you cannot write automation scripts or data pipeline. So, to learn Python basics is a must. We want to learn basics of Python. Then Python for automation scripts. Automation means using Python to perform tasks automatically instead of doing them manually. Python is used to read and write files, schedule jobs, send emails, process logs, etc. A data engineer may use Python to automatically clean daily data files. The automation saves time, reduces errors, and increases efficiency. Python for data pipelines. A data pipeline is a flow where data moves from source to destination. Python helps in extracting data from databases or APIs, transforming data like cleaning, filtering, aggregating, etc. Then loading data into data warehouses. Then tool used for these are Pandas, NumPy, Airflow with Python. Even night Python scripts run to move data from production systems to analytic systems. Python for APIs and backend logic. Python is a widely used to build backend systems and APIs used for creating REST APIs, connecting ML machine learning model to applications, handling requests to and responses. The frameworks used are Flask, Fast API, Django, etc. For example, when a user requests predictions from a model, Python backend logic handles that request. Then, why data engineers and ML engineers use Python? Data engineers and ML machine learning engineers use Python because it connects everything. Python is used to build data pipelines, train machine learning models, deploy models as APIs, automate workflows, integrate with cloud services. So Python acts as a glue between data, models and systems. In real companies, Python collects data, processes it, trains models, exposes predictions through APIs, and runs continuously in production. If you want to become a data engineer or ML engineer, Python is not optional, it is mandatory. So, learn Python is important. Then, next is databases, which includes SQL and NoSQL. In data science, and software systems, data must be stored, managed, and retrieved efficiently. For this, we use databases. Databases are mainly divided into SQL and NoSQL databases. First one is a SQL databases, which also known as a relational database. SQL, structured query language. Databases store data into a structured format using rows and columns, similar to an Excel table. For example, MySQL, PostgreSQL. Key features for that are fixed schema, tables with relationships, uses SQL, structured query language. Each column has a predefined data type, so the structure is a strict. For example, in a student table, name, roll number, and marks are clearly defined. SQL databases are best when data is structured and consistency is very important. The next one is a NoSQL, non-relational database. NoSQL databases are designed to handle semi-structured and unstructured data. For example, MongoDB. Key features for that are flexible schema, data stored as a documents like JSON, then easy to scale. You don't need you don't need the same structure for every record. For example, one user document may have a phone number, another may not. In this case, we use MongoDB. The NoSQL databases are ideal for large scale applications and fast changing data. Then structured versus semi-structured data. Structured data follows a fixed format like tables. Semi-structured data uses flexible formats like JSON or XML files. SQL versus NoSQL. SQL focuses on structure and consistency while NoSQL focuses on flexibility and scalability. For example, banks mostly use SQL databases for transaction. Social media and real-time apps use NoSQL databases like MongoDB. In modern data systems, SQL and NoSQL are often used together depending on the type of data and application's needs. This is all about the databases. Then next we will see data handling libraries. In data science, raw data is a useless until we clean, process, and analyze it. Python provides powerful libraries for this purpose, Pandas and NumPy. These two libraries are the foundation of data handling and numerical computation. First one is a Pandas. Pandas is used for data cleaning and data manipulation. Then what is a Pandas? Pandas is a Python library used to work with structured data like Excel files, CSV files, and databases. Pandas works mainly with series and data frame, 2D table like data. Then Pandas for data cleaning. Real world data is messy. Pandas helps us clean data before analysis or model building. Data cleaning task includes handling missing values, then removing duplicates, renaming columns, fixing data types, handling incorrect data. This all operation is done in a Pandas. For example, if salary values are missing or written incorrectly, Pandas helps fix the easily. Then Pandas for data manipulation. Data manipulation means changing, transforming, or reorganizing data to make it useful. Pandas helps with filtering rows, selecting columns, then sorting data, grouping data, merging and joining data sets, etc. We can group sales data by region and calculate total revenue. This is example of data manipulation. Then pandas turns raw in short, pandas turns raw data into meaningful information. Then second one is a NumPy, numerical computing and arrays. What is NumPy? NumPy is a Python library designed for fast numerical computation. It is it is the backbone for pandas, machine learning libraries, deep learning frameworks, etc. NumPy for numerical computing. NumPy is optimized for mathematical and scientific calculations, used for mathematical operations, statistical calculations, linear algebra, random number generation. For example, machine learning models rely on NumPy for fast calculations. Then arrays and matrices in NumPy. Unlike Python lists, NumPy arrays are faster and memory efficient. Features of these are multidimensional arrays, matrix operations, element-wise operations. For example, an image is stored as a matrix of pixel values, and NumPy handles this efficiently. In Pandas versus NumPy, NumPy focuses on numbers and performance, while Pandas focuses on data analysis and structure. Pandas is a built on top of NumPy. Real world example for this in real projects, NumPy performs fast mathematical operations. Pandas cleans and organize data. Together, they prepare data for machine learning models. If Python is a language of data science, then NumPy and Pandas are its core engines. So, this all about the data handling libraries in Python. Then next is data visualization. After cleaning and processing data, the next important step is data visualization. Visualization helps us see patterns, trends, and insights that are not visible in raw numbers. Good visualization helps both technical team and business stakeholders make better decisions. Then Matplotlib and Seaborn for exploratory data analysis. What is exploratory data analysis? EDA is the process of usually exploring data to understand its structure, pattern, and behavior. EDA helps to identify trends, detect outliers, understand distributions, find relationship between variables. Then Matplotlib. Matplotlib is a basic plotting library in Python used for line charts, bar charts, histograms, line charts, bar charts, then histograms, scatter plots, etc. Matplotlib gives us full control over plots and it is used heavily during analysis. We can plot cells over time to see growth for or decline. Then next is Seaborn. Seaborn is a built on top of Matplotlib and provides better looking and statistical plots used for correlation, heat maps, box plots, pair plots, distribution plots, etc. Then Seaborn makes it easier to identify relationships and patterns in data. For example, a heat map can show how strongly features are related. In pattern and trend identification, using Matplotlib and Seaborn, we identify hidden patterns and trends. For example, sales increasing over months, customer behavior patterns, seasonal trends, and anomalies or outliers, etc. Visualization helps run data into understanding. In Power BI and Tableau, for business dashboard and reporting. These are used. Why business intelligence tools? Technical plots are useful for analysts, but business teams need dashboard, not code. So Power BI and Tableau are used to create interactive dashboards, build reports for stakeholders, share insights easily. Power BI and Tableau are business intelligence tools used for professional reporting. Key features of these are drag and drop interface, real-time data updates, interactive filters, and easy sharing. Managers can understanding insights without knowing Python. So Power BI and Tableau are used in business dashboards. Dashboards provide a high-level view of key metrics, for example, sales performance, profit analysis, customer segmentation, operational KPIs, etc. One dashboard can summarize the entire business performance. Then reports for stakeholders. Reports communicate insights clearly to decision makers. Stakeholders includes manager, executives, clients, etc. In short, good reports focus on insights, not raw data. So we use Power BI or Tableau for making a dashboards. Python visualization versus BI tools. Matplotlib and Seaborn are used for analysis and experimentation. Power BI and Tableau are used for business communication and decision making. Data visualization bridges the gap between data analysis and business decisions. This all about data visualization. Then we will see next slide, which is machine learning. After understanding data cleaning it and visualizing patterns, the next step is a machine learning. Machine learning allows systems to learn from data and make predictions or decisions automatically. In Python, the most widely used library for core machine learning is scikit-learn. What is scikit-learn? Scikit-learn is a Python library that provides simple and powerful tools for machine learning, used for building machine learning models, then training and testing models, evaluating performance, training models. It supports most classical machine learning algorithms used in industry. Then regression. Regression is a used when the output value is continuous. House price, for example, house price this belongs to. Then next one is a clustering. Clustering is an unsupervised learning technique, meaning no labeled output is provided, used for customer segmentation, market analysis, pattern discovery. Common clustering algorithms are k-means, hierarchical clustering, then clustering group similar data points together. The next one is a model evolution and tuning. After training a model, we must evaluate how well it performs. So evolution matrix, which includes regression, RMSE, MAA, R square, etc. Then classification, accuracy, precision, recall, F1 score, etc. And clustering is used to see how score. Then evolution helps us understand whether the model can be trusted. The next one, model tuning, which is hyperparameter tuning. Model tuning improves performance by adjusting parameters. Technique used for these are grid search, random search, cross validation, etc. Tuning helps avoid overfitting and underfitting. Real world industry flow. In real projects, data is prepared, a model is selected, training using scikit-learn, evaluated, turn, and then deployed. Scikit-learn is the foundation of machine learning for data scientists and ML machine learning engineers. So, this is machine learning. Then we will see next slide, which is advanced ML and AI, machine learning and artificial intelligence. After learning classical machine learning with scikit-learn, the next step is advanced machine learning and artificial intelligence. So, advanced machine learning is used when data is large, complex, and unstructured, such as images, text, audio, and time series data. Then, deep learning and neural networks. Deep learning is a subset of machine learning inspired by the human brain. It uses neural networks with multiple layers to learn complex patterns used when data size is very large, features are complex, manual features engineering is difficult. Then TensorFlow and PyTorch. What are TensorFlow and PyTorch? TensorFlow and PyTorch are deep learning frameworks used to build neural networks. They help in designing neural network architectures, then training deep learning models, then running models on GPU and TPU, deploying models to production. TensorFlow is widely used in production systems, while PyTorch is a popular for research and experimentation. Then neural network, how they work. A neural network consists of input layers, hidden layers, and output layers. Each layer learns representation. Weights are adjusted using back propagation. Models improve through training. In image, for example, in image recognition, neural networks learn edges, shapes, and objects automatically. Then XGBoost and Light BGM. What is XGBoost and Light GBM? XBoost, extreme gradient, and Light GBM means gradient boosting machine are advanced gradient boosting algorithms used for structured or tabular data, high accuracy, then computation machine learning problems. They are faster and more powerful than traditional tree based models. Why high performance ML? Industry scales problems require models that are fast, accurate, and scalable. XGBoost and GBM offers parallel processing, handling missing values, then feature importance, regulations. Then, for example, banking, finance, and recommendation systems rely heavily on these models. Industry scale models handle millions of records and features used in credit scoring, fraud detection, search ranking, demand forecasting, etc. These models must balance accuracy, speed, and cost. Deep learning is best for unstructured data like images and text. XGBoost, XGBoost and Light GBM are best for structured business data. For example, in real companies, deep learning handles images, voice, and language. XGBoost handles business data, and both are deployed in production systems. Advanced ML and AI power the most intelligent systems we use today. It is all about the advanced ML and AI. Then next one is big data technologies. Big data technologies are designed to handle extremely large volume of data that cannot be processed efficiently on a single machine. Modern organizations generate massive amounts of data from transactions, sensors, social media, and logs, which requires distribution systems to store and process data reliably. Big data tools divide data across multiple machines, process it in parallel, and ensure scalability and fault tolerance. Then Apache Spark is a powerful distributed data processing engine widely used in a big data analytics. It processes data across multiple nodes simultaneously. enabling fast computing through in a memory processing. Unlike traditional batch systems, Spark can handle batch processing, real-time streaming, machine learning, and SQL-based analytics within a single framework due to its speed and flexibility. Spark is a heavily used by data engineers and data scientists for large scale data transformation, analytics, and model preparation. The next one is a Hadoop ecosystem. The Hadoop ecosystem provides the foundation for distributed storage and batch processing of big data. At its core is HDFS, Hadoop Distributed File System, which stores large datasets by splitting them into blocks and distributing them across multiple machines. HDFS is a fault tolerant, meaning data remains accessible even if some machines fail, making it suitable for enterprise scale data storage. The next one is a MapReduce basics. MapReduce is the original data processing model used in Hadoop. It works in two main steps. The map phase processes and transforms data into key value pairs, and the reduce phase aggregates and summarizes the results. While MapReduce is reliable for large batch jobs, it is slower compared to modern engines like Spark because it relies heavily on disk based processing. In real world industry, organizations often use HDFS for scalable storage, Spark for fast distribution, data processing, and other Hadoop ecosystem tools together to build robust big data pipelines. These technologies are widely applied in banking, e-commerce, healthcare, and telecommunication to analyze massive data sets, generate insights, and support data driven decision making at scale. This all about big data technologies. Then cloud platforms. Cloud platforms provide on demand computing resources that allow organizations to store data, train machine learning models, and deploy applications at scale without managing physical infrastructure. The three most widely used cloud platforms in the industry are AWS, Microsoft Azure, and Google Cloud Platform (GCP). Each platform offers powerful services for data storage, machine learning, and scalable deployment. So, first one is Amazon Web Services, which is AWS. AWS Amazon Web Services is the most widely adopted cloud platform and offers a broad range of services for data science and machine learning. For data storage, AWS provides services like Amazon S3 for storing large datasets, then Amazon RDS for relational database, and then DynamoDB for NoSQL storage. For machine learning model training, AWS offers services such as Amazon SageMaker, which allows data scientists to build, train, and deploy machine learning models efficiently using managed infrastructure. In terms of scalable deployments, AWS supports auto-scaling, load balancing, and container services like ECS and EKS, enabling applications and machine learning models to handle varying workloads smoothly. The next one is a Microsoft Azure. Azure is strongly integrated with enterprise and Microsoft based ecosystems. For data storage, Azure offers Azure Blob Storage for unstructured data, Azure SQL dataset for relational data, and Cosmos DB for globally distributed NoSQL data. For machine learning, Azure Machine Learning provides tools for training, experimenting, and managing ML models with built in supports for popular frameworks. Azure excels in scalable deployments through services like Azure App Services, Azure Kubernetes Services, AKS, and seamless integration with DevOps tools, making it a preferred choice for enterprise level deployments. This this is Microsoft Azure. Then next one is a Google Cloud Platform, GCP. Google Cloud Platform is known for its strength in data analytics and artificial intelligence. For data storage, it offers Google Cloud Storage for large datasets and BigQuery for fast, scalable, and data warehousing. For machine learning model training, Google Cloud Platform provides Vertex AI, which simplifies training, tuning, and deploying machine learning models using Google's advanced infrastructure. In terms of scalable deployments, Google Cloud Platform supports container based deployment using Google Kubernetes engine and serverless services, allowing applications and machine learning models to scale automatically with demand. In short, AWS, Amazon Web Services, then Microsoft Azure, and Google Cloud Platform GCP all support data storage, machine learning model training, and scalable deployments, but each has its own strength. AWS is a widely used and feature rich. Azure is an enterprise focused with strong Microsoft integration, and GCP, Google Cloud Platform, excels in analytics and artificial intelligence. Together, these cloud platforms enable organizations to build, train, and deploy data driven and AI powered systems efficiently and at a scale. This is all about the cloud platforms, which include the AWS, Azure, GCP, etc. The next one is deployment and MLOps. So let's see, deployment and ML ops focus on taking machine learning models from development to production and maintaining them reliably over time. Building a good model is only half the job. The real value comes when the model is deployed, used by real users, and continuously improved. Tools like Flask, Fast API, Docker, Git, and GitHub play a crucial role in this process. Flask and Fast API are a Python framework used to create model APIs. A model API allows other applications to send data to a trained machine learning model and receive predictions in real time. For example, a fraud detection model can be deployed as an API where a banking application sends transaction details and receives a fraud or not fraud response. Flask is a simple and lightweight, making it suitable for basic APIs, while Fast APIs is a faster and supports automatic API documentation and high performance, making it ideal for production level ML systems. The next one is a Docker. Docker is a used for container containerization, which means packaging the machine learning models, its code, and all dependencies into a single container. This ensures that the model runs the same way on a developer's laptop, a testing server, or the cloud. For example, a recommendation model trained in a Python with a specific library versions can be placed inside a Docker container and deployed on AWS or Azure without compatibility issues. Docker helps achieve consistency, scalability, and easier deployment across environments. This all about Docker. The next one is a Git and GitHub. Git and GitHub are essential for version control and collaboration in MLOps. Git tracks changes in a code, allowing developers to maintain different versions of models and pipelines. GitHub acts as a central repository where teams collaborate, review code, and manage projects. For example, one data scientist can work on a feature engineering while another improves the model, and GitHub merges their changes safely. It also helps maintain history of experiment and supports continuous integration and deployment, which is CI/CD. Then in real life, real world system, Flask or Fast API expose the model as an API. Docker packages it for deployment, and Git and GitHub manages the code and collaboration. Together, these tools ensure that machine learning models are reliable, scalable, and ready for production, forming the backbone of modern MLOps practices. Then next is industry use cases. So let's see industry use cases. Data science, machine learning, and AI are widely used across industries to solve real world problems and improve decision making. Each industry applies these technologies in a different ways based on its data and business needs. In the IT industry, data science is used for automation and analytics to improve efficiency and system performance. Automation helps reduce manual effort by automatically monitoring system, analyzing logs, and resolving issues before they become critical. For example, analytics tools analyze server logs and application metrics to predict systems failure or optimize resource uses. IT teams also use data driven dashboard to track performance, detect anomalies, and improve service reliability, enabling faster and smarter operational decisions. Then, in the finance sector, machine learning play a critical role in fraud detection. Financial institutions analyze transactions data to identify unusual patterns that may indicate fraudulent activity. For example, if a credit card is suddenly used in a different country or shows abnormal spending behavior, ML model can flag it instantly. These systems continuously learn from new transaction data, improving accuracy over time and helping banks prevent financial losses while ensuring customer security. In healthcare, data science is applied to disease prediction and diagnosis. Patient data, such as medical history, lab reports, and imaging data, is analyzed to predict the likelihood of diseases at an early stage. For example, machine learning models can predict the risk of diabetes or heart disease based on patient data, enabling doctors to take prevention measures. This leads to this leads to better treatment outcomes, early diagnosis, and personalized healthcare. Then, in the manufacturing industry, machine learning is used for predicting maintenance to reduce downtime and operational costs. Sensors installed on machines collect data related to temperature, vibration, and usage patterns. ML models analyze this data to predict when a machine is likely to fault. Overall, these industry use cases show how data science transforms raw data into actionable insights, from automating IT operations and detecting financial fraud to predicting disease and maintaining machinery. Data driven systems helps organizations improve efficiency, reduce risk, and make smarter decisions. This all we see in the industry use cases. The next one is a career roles. So let's see. First one is a data analyst. A career The career goal of a data analyst is to transform raw data into meaningful insights that supports business decisions. They focus on data cleaning, visualization, reporting, and statistical analysis. By identifying trends and patterns, Data analysis helps organization optimize processes and improve performance. For example, a data analyst might create dashboards to show sales trends or customer behavior to help a company take informed actions. The next one is a data scientist. A data scientist aims to solve complex problems and predict future trends by leveraging advanced analytics, machine learning, and statistical models. They focus on predictive models, data mining, and algorithm development. Their work drives data driven strategies and innovation, helping business make strategic decisions. For instance, a data scientist may build models to forecast production, demand, or detect potential risk in a business operations. The next one is a machine learning engineer. ML engineers focuses on designing, building, and deploying machine learning models to automate tasks and enhance decision making. They work on model development, optimization, development, and scaling. Their contribution power intelligent applications like recommendations systems, fraud detections, or predictive analytics. The goal of an ML engineer is to implement ML solutions that solve real world challenges efficiently. Then fourth one is a artificial intelligence engineer. AI engineers aim to develop systems that mimic human intelligence, including reasoning, learning, and decision making. Their work includes deep learning, natural language processing, computer vision, and AI system design. AI engineers create cutting edge intelligent systems such as virtual assistants, autonomous vehicles, or smart automation solutions. Their career goal is to develop AI solutions that assist humans in solving complex problems. These are the career roles. Then next slide is a roadmap for beginners. So let's see. We will explore the career roadmap for beginners in a data machine learning and AI, whether you want to become a data analyst, data scientist, ML engineer, or AI engineer. Following this roadmap will help you build the right skills step by step. Let us understand it in a structured way. So, step one is a Python and SQL. The first step is to learn Python and SQL. Python is the most popular programming language for data work. Thanks to libraries like Pandas, NumPy, scikit-learn, SQL is essential for working with databases and extracting data efficiently. Mastering Python and SQL will give you the foundation to handle, analyze, and manipulate data effectively. Then, step number two is the data analysis. Next, we focus on data analysis here. Here, you learn to explore data sets, clean and pre process data, and understand trends or patterns. Keys like handling missing values, summarizing data, and performing statistical analysis are key. This step helps you turn raw data into actionable insights. Then, step number three is a visualization. After analyzing data, it's important to communicate insights visually. Tools like Matplotlib, Seaborn, Tableau, and Power BI allow you to create charts, dashboards, and reports. Visualization helps you tell the story behind the data clearly and effectively to stakeholders or decision makers. Then fourth one is a machine learning basics. Once you are confident with analysis and visualization, it's time for machine learning basics. You learn to train models that can predict outcomes or clarify data concepts like linear regression, classification, clustering, and evolution metrics are introduced. This step moves you from descriptive insights to predictive and pers- perspective analysis. Then, step number five is advanced artificial intelligence. After understanding ML, the next step is advanced AI. This includes deep learning, natural language processing, and computer vision using frameworks like TensorFlow or PyTorch. You can build systems like image recognition apps, chatbots, or recommendation engines This step enables you to create intelligent systems that mimic human learning and decision making. And last one is a deployment and cloud. Finally, to make your solutions usable in the real world, you need to learn deployment and cloud technologies. This includes deploying models with fast API or cloud platforms like AWS, Azure, and Google Cloud platforms. This ensures your models are scalable, reliable, and accessible to business or users. So, this is the step by step roadmap for beginners to start a successful career in data, machine learning, and AI. Following these steps will help you gain the right skills, build projects, and grow in your career. They start learning and building your path to success. Then, next is the common mistakes and tips. Before we move forward, it's important to understand some common mistakes beginners make in a data, ML, and AI, and how to avoid them. Recognizing this early will save you a lot of time and efforts. First one is a skipping fundamentals. One of the biggest mistake is skipping the fundamentals. Some beginners try to jump straight into advanced AI or ML without a solid foundation in a Python, SQL, or basic statistics. Without fundamentals, it becomes very hard to understand complex concepts later. So always focus on building a strong base before moving forward. Then second one is a only theory, no practice. Another common mistake is a learning only theory without practice. Reading or watching tutorials is not enough. If you don't write code, work on data sets or experiments, you won't truly learn. So practice every concepts with real data and small projects to reinforce learning. Then third one is ignoring deployment. Many beginners ignore deployments and real world applications. Learning machine learning or AI is a great, but if you can't deploy your models, they remain just experiments. So learn how to deploy your projects using fast API or cloud platforms like AWS, Azure, Google Cloud platforms. Then fourth one is a not building a projects. Finally, a common mistake is a not building projects. Without projects, it's hard to showcase your skills to employers or clients. Start with small projects, then gradually build large ones. Project helps you apply your knowledge, solve real problems, and create a portfolio that stands out. So remember, avoid skipping fundamentals, always practice, learn deployments, and build projects. Following these tips will make your journey in data, machine learning, and artificial intelligence smooth, practical, and rewarding. Then next we will see conclusion. Now, let's wrap up today's session. In 2026, a career in data science and AI engineering requires three key skills. First one is a strong programming skills, Python, SQL, and the ability to manipulate and analyze data efficiently. Then second one is a machine learning and artificial intelligence knowledge, understanding models, algorithms, and building intelligent systems. Then third one is a cloud and cloud and deployment skills, making your solutions scalable, accessible, and production ready. The key message is simple: start today, build consistently, and keep learning. Every small project, every line of code, and every concept you practice brings you closer to becoming a successful data scientist, machine learning engineer, or artificial intelligence engineer. Thank you all for joining this webinar. I hope you found it valuable and are motivated to start your journey. Wishing you all the best in your learning and career. This concludes our session. Have a great